Hello and welcome. This outcome is to identify the domain of a radical function. Given a radical function in the symbolic form, the student will identify the domain and write it in interval notation. So we have two examples right here. We have f of x equals the square root of x minus 3. So looking at the symbolic form of a square root function, this is a specifically square root function, we need to identify the domain of this function. What values of x? So we're thinking what values of x we can plug in there. And to find this out, we also need to look at the restrictions of what values we can have under the square root. And as you know, this is the principal root. And for a function, what's under the square root, it has to be greater than or equal to 0. It can't be a negative number. So what we do is we take the radicand, which is x minus 3, everything under the radical, and we set it to be greater than or equal to 0. And then we solve that for x to find what the domain is. So we're going to add 3 to both sides. So x is greater than or equal to 3. So that would be the domain. So how do we write the domain in interval notation? So x can be 3 or greater. So we could mark 3 right here. So it's included, 3 is included, so we put brackets and we go all the way there. Sometimes this would be a closed circle for 3. So this would be the domain of the function. So the domain in interval notation would be the closed interval at 3, because that includes 3, goes all the way to infinity. And you can tell if you plug in 3, 3 minus 3 is 0, so the square root of 0 is 0. If you plug in 4, so you have to plug in 3 or greater. 4 minus 3 is 1, square root of 1 is 1, and so on. We're going to do the same thing for this g of x. What is the domain? Again, we're going to take everything under the radical, which is the radicand, and this has to be greater than or equal to 0. We're going to solve this inequality. Now remember, when you solve an inequality, the rules of solving an inequality, that if you divide by a negative number, multiply by a negative number, you switch the inequality symbol. This is not the case here. 3x is greater than or equal to 7. Divide both sides by 3. Then x is greater than or equal to 7/3. And that would be the domain. Let's write it in interval notation. I always like to draw the number line and represent that on the number line. If that's a 0, 7/3 is 2 1/3. So that's 1, that's 2, that's 3. 2 1/3 is about here. So that's where 7/3 is. And so the values of x have to be either 7/3, that includes 7/3, or greater. And so the domain of this function is all values of x, 7/3, all the way to infinity, including 7/3. Let's go to the next slide and do 2 more examples right here. So let's look at r of x. R of x is also another square root function. So same thing, we're going to take everything under the square root, which is negative 2x plus 6 is greater than or equal to 0. Set it to greater than or equal to 0 because it can't be negative. And then we're going to solve this inequality. Subtract 6 from both sides. So we have negative 2x is greater than or equal to negative 6. Now remember, we're going to divide both sides by negative 2. But when you divide by a negative number, remember to switch the inequality symbol. So the greater than becomes less than. And so this becomes x is less than or equal negative 6 divided by negative 2 is a 3. And so that's the domain, all values of x such that x is less than or equal to 3. So that's 0, 1, 2, 3. less than or equal to 3. So it equals to 3 is going to include 3. So you put brackets there and go all the way to the left to negative infinity. So now the domain in interval notation would be, remember, go left to right from negative infinity to 3 closed at 3. All right, the next example is a cube root function. And as you know, the cube root, you can have the radicand could be positive, negative, or 0. So there are no restrictions for what goes under the square root. So the x value can be any number you want. So you don't really have to do any work here. So you're just going to say that the domain is all real numbers, negative infinity to infinity. And so for even indices, for even roots, you're going to do this process because we have restrictions on the radicand. For odd indices or odd roots, then you don't have to do anything because we could have a negative number under the cube root. As you know, if you have the cube root of negative 8, we can do that. So that's a negative 2. With the number you cube, you to get negative 8, so no restrictions here. But you can't have a negative number under the square root. See you next time.